Now we are going to determine whether the inputted number is prime or not. So let's ask the user by outputting input the number. And then we're gonna put the data type of this variable and then input the number of the user. And I'll also use is prime variable, the boolean data type, and set it as true. Now we know that 0 and 1 are not primes, so let us write it separately. If number equal to 0, or the symbol, by the way, the symbol is for or as an or operator, or number equals to 1, then we are going to set this as false, and then we are going to introduce a for loop for general number starting from 2 till number by 2, incrementing by 1 if number equals to number mod I equal to 0, which means that the remainder after dividing I after each iteration should be equal to 0, which means number is divisible by I. If this happens, then we are going to say that the number is not prime, so hence we write it as false. And finally break out of this loop. So if is prime equal to true, cout the inputted number equals to, or simply say is prime, end line. And the contrary to this statement, which is the else statement, would be cout not prime, or let's cite simply as prime. That completes the program. By the way, you would be thinking about this part because other things are pretty clear. Now what happens is, for example, if you have a number, say any number, like if you have 24, all right, so what is going to happen? You have set number equals to 24 here, and as it's not equal to 0 and 1, so it will skip this if part, if this if statement, and directly jump into this for loop. Now I is equal to 2, which I have set here, and it will go up till I which is less than equal to number by 2. Number is 24, hence it will go till 12. Number by 2 is 24 by 2 is 12. So I less than equal to 12. So what is going to happen is that 24 has many factors, right? It has 2 as its factor, 1 as its factor, 2 as its factor, 3, 4, 6, 12, 8 as well. Like it has many factors, and the number itself 24. So 1 is of no use because 1 is the factor of every number. So we are starting from 2. So I should be less than equal to number by 2. That means it should be less than equal to 12. So it will go like this. It will firstly take the remainder and check whether number is divisible or not by I. So here I is equal to 2 here in the first iteration. So we know that number, which is 24 by 2, will be divisible because 24 is divisible by 2. and hence, as it is divisible by 2, it will become a prime, not a prime number, because we have already divided this number by 2. That means it has two factors. So for even numbers it's quite easy. Let's take an odd number. Let's take 49, suppose. So what is going to happen in 49 is, firstly it will divide by 2, which is equal to 24.5, and as we know that it is an int, we have stated here it's an int, so the decimal part will go away. So 24 will be in part of this, so I less than equal to 24. We know that 49 has only two factors, which is 7 and 7, 1 as well and 49 as well. Let's write 1 7 here. So it will go from like this, like I is equal to 2, it will check whether number is divisible by 2. It is not. So as it is not divisible by 2, so it will go again up in the iteration, and then I will become equal to 3, because I plus plus is given, as it means that it will increment by 1. So I will become 3. So I will become 3, right? Let me write somewhere else. I becomes 3. Now as I becomes 3, it will check whether it is divisible by 3. It is not, so it will go back up, and then I will become 4, and then again check, it will become and as number is not divisible by 4, it will go up again and the number will turn into 5, and it will go on like this, and there will be a time that will reach 7 and see that number, which is 24 or which is 49, is divisible by 7 or not. And we know that it is divisible by 7, right? 49 has 7 as its factor, and therefore with this is prime, condition becomes false, and then it breaks out. Therefore this is important part, like it becomes false, so it means that finally when we'll print, it will be not prime. So this is the important part of the program, the for loop. Others are kind of exceptions, like 0 and 1, right? These are exceptional part of prime numbers, as we state that 0 and 1 are neither prime neither composite. So let's save and run this program. Enough talks. Oh yeah, I forgot to put semicolon here. Yeah, now it should work. Oh, did I save it or not? Yeah, it's working now. So let's put it as 24 first, as I took an example before. So yeah, of course it came out to be not prime. Let's try 49. It should be also not prime. Yep. Now let's take exceptional cases as well, or let's take a non-prime number first. It's 7, right? 7 is not a prime, is a prime number. We are checking for prime number right now. So yeah, 7 is a prime number. So this time let's try for exceptional cases 0 and 1. Yeah, it's not prime. Perfect. It's not prime. Perfect. So that explains very well. I hope you liked my program. Please give a like if you did, and subscribe if you are new here. Thanks for watching my video.